All right. I think this lab was trying to develop a vaccine vector that could be used to vaccinate the Chinese military and the Chinese people and maybe the world in general. In order for the vector to be useful, it needed certain characteristics. One, it would be a lot better if it could be spread by aerosol or droplets. It's a lot easier. It's hard to find enough needles to vaccinate billions of people, right? But if you can just spread it around by sneezing, you got something that could maybe be a vaccine. It also, and therefore making it more transmissible, which we now know it is interesting, Chris, if you look critically, and I've always wondered why this wasn't pointed out in some of the interviews. If you look at COVID-19, which my critics say came from bats to some animal and then to people and then became very infectious in people, when, even though it's not like SARS or MERS, because it couldn't do efficient transmission in people, but when you look at that virus that now is in people and take COVID-19 and ask the question, can it infect bats? It's very inefficient in infecting bats. How'd that happen? Right? Well, it was engineered to change its receptor, so its preferred receptor was the human receptor.
Right.
The second thing, if you're going to make a vaccine vector, for people, you want to make people not sick. So if you look at the virus, there's pretty good evidence that it also has been manipulated to knock out what we call the interferon response element. So when you get a cold or flu and you ache all over the place, that's not the flu virus doing it. That's your interferon response element. They knocked out the interferon response element. The other thing they did, and there's some really good scientists at Livermore that have pointed all this out. There was a congressional hearing a couple years ago where they presented a group of virologists. It wasn't well reported on, but it was a very good hearing on the virology of this virus. They also modified what we call the immunodominant response, so that when you get this virus, your body doesn't orchestrate an immunodominant response that would make it impossible to use the virus again. So this virus could be given over and over and over again. So I think it was developed as part of a vaccine program, which was trying to develop vector which could be then used for multiple antigens. So if you wanted to vaccinate the population against this disease or this disease or this disease, all you had to do is insert that antigen into this vector. And I think personally, that's what they were trying to do. I can't prove it. That's just an opinion. But I think that's what they were doing, as opposed to trying to create a virus. If you want to look at it from a military perspective, and I spent 23 years at Walter Reed in the U.S. Army Medical Corps, the target population for, let's say, a bioweapon agent would not be those of us over 65.
Right. You want to get the young ones.
The target population would be 18 to 30 years old.
Right.
Okay? And this virus doesn't do anything really to those people in general. I mean, some people get sick, but in general. So I really think it was a vaccine vector, part of a major vaccine vector program. I think the problem with what I call scientific arrogance about all the people that were doing this work, they never really realized that they were kind of unlikely being able to contain a respiratory pathogen, particularly in the laboratory situation that they were doing it. I've mentioned to people when I was CDC director, one of the most difficult decisions I made was I shut down Fort Detrick. I had been at Walter Reed for many years. I had worked at Fort Detrick. These are my colleagues. But CDC normally inspects these laboratories for their biocontainment adherence. And they had some problems with the inspection. And then the follow-up inspections, they had the same problems. And I felt it was just inappropriate for them to go on doing those experiments, particularly for the people of Frederick and the area around there, because they had some very serious lapse in their biocontainment strategy, and I shut them down. They were shut down for about 6 months. So I think there was a lot of arrogance here. We know that the containment in this laboratory was not optimal, but I will also say, and maybe we'll talk about it later, I'm very worried about gain-of-function research that's being done in a lot of university labs that don't have the containment to do it.